Amazing. So let us jump into data guard architecture. So guys, in data guard, the first goal that everyone has is, if you have a primary server, you need to set up a physical standby, right? So that means our goal is to first learn how physical standby works, and then only we will be able to understand other types of data guard architectures. And I think other types of architectures are just modifications of physical standby. So first we need to understand how physical standby works. So let us start with the primary database, right? You have a database. This is primary DB. Now on primary database, we know that there is redo log buffer. So what exactly is redo log buffer? It is the area where redo logs are copied. It is the area in the instance where redo log entries are written and flushed out, right? So which is the background process which is responsible for flushing out the redo log entries? It is log writer, correct? Let us give a fancy background to log writer. And what log writer does is, log writer will write the redo log entries into online redo log files, right, in a cyclic order, if you remember. Online redo log files, correct? And from the redo log files, we also know that there is an archiver process, right? We'll again give a fancy background, and the archiver process is responsible to write these redo log files into archive log files, right? This is the basic setup. We all know this is how a standalone database works. But what happens in a data guard configuration is, you have another process that is directly reading from your redo log buffer, and this new process is known as LNS, log network service. Technically it is also called as log writer network service. So this background process is responsible to read the redo log buffers directly from your primary database and pass it over on the network to the physical standby database. So we'll understand what happens on the physical standby database side. But once again, log network service is the background process. Its job is to read from the redo log buffer of the primary database and send the redo log entries on the network. Now this is Oracle Net Service. So like how we set up client and server networking in Oracle, that's the same exact networking you need to set up between primary and standby. So on the standby server, so guys, remember this is where these two are completely different servers, right? Now on the standby side, definitely there needs to be a process which is accepting the buffers, right? So on the standby side, there is a process called as RFS, remote fetch service. Some people also call it as remote file service, but I think it's you can also call it remote file service, and you can also call it remote fetch service, and you will understand that why it has a different name, remote fetch service, in some time. So on the primary server, LNS is responsible to send the redo log entries directly by reading from the redo log buffer of the primary instance over the network to RFS. So if we go back to our simple architecture that I have shown yesterday, these two services are combinedly known as log shipping service, right? So LNS is responsible to ship the logs, RFS is responsible to accept the logs. All right. Now, what does RFS do when those redo log files or the redo log buffers are received from the primary. The RFS is responsible to write the redo log files into something called as, these are again standby redo log files. These files are different than the redo log files. These are a special kind of redo log files and the name is standby redo log files. So of course your standby database will have its own redo log files and I'll talk about it in some time, but you need to configure as a DBA when you're creating the physical standby, we configure standby redo log files. So these redo log files are the ones where the redo log entries from primaries are written onto these standby log files. And from these standby log files, what happens is you have an MRP process. So this MRP process is responsible to read from the standby redo log files and apply it onto the physical standby database. Alright, so this MRP is not the one that you see on the products. Maximum retail price, no, it is managed recovery process. If you remember our simple architecture, I mentioned like you have a log apply service. So this MRP is the exact log apply service that is available on the standby. So it runs on the standby server. So guys, anything on the right side of this line is like your physical standby server and this side is your primary server. Okay, consider this as two separate servers. So this is very basic architecture of the data guard, but there are some scenarios in it. And of course, I understand like we have all the experienced DBAs over here. And let me talk about those scenarios because you would be much more interested in those scenarios. So what happens guys, sometimes let's take there is an activity going on in the primary database and the redo logs are being generated at a very high pace. So sometimes what happens is your LNS is not able to capture the redo log entries as fast as your log writer is writing them onto redo log files. I repeat, sometimes there are some activities on the production server where LNS is not able to read the redo log entries from the redo log buffer cache as fast as log writer is writing those entries onto the log files. So what happens is in this kind of scenario, if LNS is running behind the log writer or log writer is very fast in capturing the logs from the redo log buffer and writing onto the log files, in this kind of scenario LNS can easily switch to reading directly from the redo log files. So that's the beauty over there. If LNS is not able to read from the redo log buffers, it can read from the redo log files because LNS knows from which redo log file it has to read. Alright, now this is the beauty about the LNS, and just some time back I mentioned this is also known as remote fetch service or remote file service. Alright, sometimes what happens is there is a gap. What is a gap? Like your log number on primary is 50 and on standby the log number is 25. Alright, now there is a huge gap, right? In this kind of scenario, what happens is the RFS process, and this is the reason it is known as remote fetch service. The RFS process is able, it can definitely identify that there is a gap, and to resolve this gap, RFS process can go to your archiver process on the primary. RFS will speak with the archiver process on the primary and it will start pulling these archive logs onto the standby server, the archive logs which are required. And this process is known as gap resolution. So but there is a condition. If all the archive logs after the log number 25 are available, then RFS is smart enough to resolve the gap automatically. But sometimes what happens is Armen is also running on the primary server. So what Armen will do, as the archives are created, it will back up those archive files and delete them. So in this kind of situation, definitely you won't have archives, and as a DBA you have to manually resolve the gap. Once again guys, let us assume there is a huge gap. In that kind of scenario, RFS is smart enough to identify the gap. It will contact the archiver process on the primary, and it is capable of fetching. That is why it is known as remote fetch service. So it is capable of fetching the archive files onto the standby server. And once these files are on the standby server, it will start again, the MRP will start applying these files to the standby database. And that's how a physical standby works. So guys, doubts, most welcome. This is the actual architecture of the data guard. So this Linux installation is continuing.
Arun, Satish here.
Yes, Satish.
Now when the data is shipped from primary to standby, there's a lot of ways where the data is getting shipped, like redo log buffer, then from redo log file, and from archive file.
Don't get confused. What I mentioned, if LNS is running behind a log writer, then it will read from this redo log files, and if there is a big gap, then RFS is able to capture the archive log file. So this is process 1, this is step 2, step 3. Yeah, go ahead.
Yeah, that is which means under various scenarios, depending on the scenario, the difference in log and data, it gets shipped out.
Correct.
Okay, either it like first condition, second condition, or third condition.
Right, perfect.
Okay, now how do we know that when we have a primary and standby setup? How do we know that where is the issue and how to lay our hands on and how to resolve this issue? Because we had a similar type of issue in our environment set up some time back, and no one knew how to fix this issue.
So that means you, I think that's why you are in the training, so you will understand. The gap resolution is a completely different topic, and we are going to learn about it. So how to find the gap, and I think most of the times the data guard issues are because DBAs are lacking. First of all is the knowledge, and second is the right queries. If you have the right queries, they will give you the exact answers to your problems, where the problem is in the data guard environment. And once you know the problem, then it's always a cakewalk to solve the problem.
Okay. In the third step, you said that in case there is a huge gap between the primary secondary log, the archive log file gets shipped. Is it automatically done, or there should be some manual process?
All automatic. Till here, everything is automatic. The problem starts if Armen has already backed up the archive log files, even though they are not shipped. Of course, now in 12C, I think in 11G, 11.204 also, the Armen is smart enough, and you can force Armen to not to back up the archive logs which are not applied onto the standby. But still, I have seen, even though Oracle claims that Armen is so intelligent, but many a times I have found that Armen is backing up the archive log files and deleting it faster onto the primary before they are applied on standby. In those kind of situations, you have to jump in and resolve the gap. And guys, it is not always the problem with the archive. What if there is a network issue? What if the physical standby is down? What if there was the last process is down? What if RFS is down? What if there was a problem with LNS? So problems might be at multiple stages. So it depends, yeah.
Okay. So one other question is, MRP is also known as log apply service?
Yes, but don't get yourself confused. We'll talk about it later, not right now. So in a physical standby, it is known as MRP, and I think we'll limit our understanding till that point for now. So guys, we see that almost the installation is done.
Hi, Arun.
Yes, Abu.
What would happen to the after apply the logs, what they call a standby redo logs, and after apply, what happens to standby redo logs?
Nothing. They are like normal redo log files. They will be overwritten back to back. Like how in redo log files, if you know,
Right. Okay.
the redo log files are
Right.
overwritten, right? In a cyclic manner.
Correct. Correct.
Yeah.
Yes.
So they will continue to.
So it won't be copied as archive.
No, you can set up that. You can set up that. It will be definitely, there is a way. If you set up the archiver process on the standby, then you can again copy them to the archive log files. But the problem is there is a challenge over here. Can you see? You are taking two copies of the archive log files. One is on the primary, one is on standby. So, it's not recommended. So, Kenneth, Arun, can you please throw more light on the RFS standby redo logs connection? Connection as in, Kenneth, is it something specific you're asking? But as you ask this question, I have one thing that I want to talk right now, and good that this question has come up. So guys, the next question you should definitely have is, what is the difference between standby redo log files and redo log files? This is again a very important interview question, and this is something you should know. So on primary, this is your primary. You will definitely have redo log files, right? And they always work in a cyclic order, right? On the standby, definitely you also have redo log files. Now this will confuse some of you, right? So this redo log files will also work in cyclic order, but the question is when? When will these redo log files will become active? When the standby is not in mount mode, because standby is generally in mount mode, and in mount mode definitely no redo log files will be generated. So these normal redo log files, I'm talking about normal redo log files, they stay there as it is, because once you switch the roles, once primary becomes standby and standby becomes primary, that point of time the normal redo log files will become active. Alright, so this is the reason what happens is you have another set of redo log files which are known as SRL. So these redo log files, your LNS process is responsible. It will take the redo log entries and send it over network to RFS, and RFS will write the entries onto SRL. Now you might have this question like, why is it writing on SRL? Why is it not writing on redo log files? It is always good to keep things separate, because these are standby redo log files and we are getting entries from the standby database. And the same way you have MRP, which is constantly writing or applying these log files. So the next question is, why this kind of configuration? This configuration is very important. Let's take, if you convert your physical standby into logical standby, or maybe active data guard, or some other configuration, what happens is your MRP is still up and running and it is applying the logs in the backend even though your database is up and running. So if your database is open, it needs normal redo log files to write the current database operations, correct? So that's the reason what happens is the normal redo log files are separate than the SRLs. The next important question is, does that mean only standby has the standby redo log files? No. The thing is, when we are configuring our data guard, you have to configure the SRL on both primary and standby. The reason is once the role switches happens, your primary becomes standby. That means these SRLs will become active, this LNS process will be gone, LNS will be started over here, and this RFS is gone, new RFS is started on the original primary, and the logs shipping start in the reverse direction. This RFS will start writing onto the SRL on the primary, and from the SRL MRP will be initiated. MRP will continue to write onto the new standby. So if you want to perform failover or switchover, in that case you need to make sure you have SRL on both the sides. Definitely you need to have the SRL on the standby, but if you want to perform failover and switchover, make sure you have created SRLs on original primary also, otherwise you cannot perform failover and switchover. There are so many databases and DBAs I have seen in real time. Of course, they never got a chance to perform switchover or failover, and they proudly say that they have a standby database. So when I talk to them and if I ask them, hey, do you have standby redo log files configured on the primary, and they will say, come on Arun, standby redo log files are for the standby database. Okay, I 100% agree. But in a failover and switchover, the primary is converted into standby, right? So if you want to convert your primary into standby in future, then you need to configure the SRLs. If SRLs, standby redo log files, are not configured, then you cannot perform a failover or a switchover. I think, Kenneth, I was able to help you with the answer. I'm not sure if that was your question. But this is one of the important things that I ask in an interview most of the times, like what's the difference between yeah. Yes, Subbu?
Yes,
Yeah,
thank you. That was a clarification I was looking for. Thank you.
Oh, all right. No worries.
what would happen in case of a reincarnation or a reset log database?
See, for that also nothing will happen. How, like I'm trying to make it so simple for you. So if you are executing a query on the primary database, that goes as it is on to the standby. So the primary database, if it moves into a new incarnation, definitely your standby as it is block by block same as your primary database, it will also move into the new incarnation. So there is no difference over there.
I see.
Yeah.
Thank you.